Okay, so we'll start with a bunch of definitions and a bunch of kind of motivating applications. I'll start with the possible applications. I really would prefer, if you have any questions, ask me as we go. Don't wait till the end, because I can go in many different directions. I can emphasize different things. And so if you're interested in something and want to clarify, just ask before I move on to another topic. So what is automatic summarization? Here is a definition that you often see in various papers. It's from Inderjit Mani's 2001 book called Automatic Summarization, and there he gives this definition of what summarization is. To summarize a document, it means to take an information source, extract content from it, and present the most important content to the user in a condensed form and in a manner sensitive to the user's or application's needs. And you can read this and say, well, this can mean many different things, right? So this is vague enough that like any moment to specify exactly what the information source is or exactly what does it mean to extract content, you might get a different task, right? So for example, extracting content might be the information extraction that we were just talking about in the previous lecture, or it might be something completely different. I'll be telling you about different ways of extracting knowledge that would be almost disappointing. You can say, like, you can ask me, are you sure this is extracting knowledge? So in a way, what I'll try to do today is to show you the kind of range of what the summarization task can be, depending on how you define precisely what the information source is and what it means to do content extraction and understanding. So one of the unspecified things in this definition is you present the information to a user in a condensed form. So how condensed? Like how much shorter should a summary be compared to the text? Well, most work that you see and read about in conferences is on summarization of news, and very often a summary is supposed to be something like a paragraph of about 100 words. But you can say, well, if you're summarizing a single news article, maybe 100 words is too much. Like maybe it's like about the size of the article itself. Do we really need such summarization? Maybe we need something like a headline if we only have one article and have like 10 words to tell us what it is about. Or if we are summarizing a book or a 2-hour meeting and we just want to know what happened during the meeting, paragraph might not be even enough to give an overview of what the book or the meeting is about. So really the compression, kind of how much condensation you want, is something that you have to define for your specific application and specific system. And actually very recent work, so this is from last year, from people at the semantic search people. Help, please.
PowerSet?
Yes, PowerSet, thank you. So PowerSet, people at PowerSet did the study where they actually asked, they said, well, why should we always say a summary is 100 words? Can we actually experiment with what happens? Can we have a query? So they had this query, here the example is, who was the person to scale K2? And then what if we have summaries of different sizes? So here you can see various condensation, like a paragraph. The Italian expedition finally succeeded in ascending to the summit on that and that date. The expedition was led by that person, but the climbers who actually reached the top were Lino and Achille. Or you can have just one sentence, right? You can have this sentence that says, these are the two people who reached first. Or you can have a phrase. You ask a who question, and you're told, like, who first climbed it? You say the two names of the two people, no additional information. So either of this is a good summary, right? You would say any kind of the paragraph, the sentence, the phrase. They're good responses to the queries. They're good summaries of some underlying information. But when should we display one and when should we display another type? And in that study that PowerSet people did, they used Mechanical Turk to exactly study this type of question. They gave people queries and they asked, what do you expect would be the type of answer for this query? So for example, this was a query that expected a person as an answer. And then they further asked, okay, for what would be the ideal summary, the length of summary that you would want. And it turned out that there were very strong preferences. So here the numbers give you what people wanted for each type. So here the first column gives you the type of answer a query might be related to. And this side gives you whether you would prefer to see a phrase, a sentence, a paragraph, the full article that's relevant to your question, or some list or a combination of both. So when you have a question that asks for a person, actually the majority of people said, I just want a phrase. I don't want your paragraph. I don't want more background. I prefer a phrase. You can see, for example, if something is a gossip, actually people wanted to read more. They wanted a full paragraph or the full article. Same with reason and cause. Like if I'm asking a question that's about, give me the reason for an event or the cause of something happening, no one wanted a phrase. People wanted either a full article or a paragraph. So really kind of, what does it mean to find the relevant and condensed information? It depends on what the user is looking for. And kind of what I'm showing you here is something somewhat new in summarization. For a while, people were like, okay, we want 100-word summary. Let's see how to do the best 100-word summaries. But more and more, really, if you're thinking about application, you need to know what your user wants. And you need to know what is the right kind of condensation form, answer form for what the user wants. So this is kind of exciting. I'm trying to give you a sense of the range of the type of work that people are doing. So kind of this is one open question now. In a given information seeking situation, can we automatically predict what would be the best type of output for the user? So kind of what is the user looking for, and what sort of output do our summarization system need to give? So another thing that was left unspecified in that Mani description was the type and genre of the input. Like it just said information source. Well, information can be text, right? We can have all sorts of written documents. Or it could be speech. It could be broadcast news or a telephone conversation, or it could be a video of some event, right? So obviously the way you would do the understanding of the source would certainly be influenced by what sort of input you get. And some of the types of genres are news. A lot of the research has been done on news, and also scientific articles. Thinking about applications, I think scientific articles would be much closer to the heart of most people in this audience, right? Who follows news? Like, well, intelligence analysts, people on Wall Street, and like for more science-oriented people, it would be really nice to have some help with scientific articles, finding what's relevant, finding what's... So this is another type of input that would probably take different sort of analysis in the kind of understanding part of summarization. And then there is, of course, email and spoken conversations and chat. And Can someone see, like, do we really need to talk about the applications of summarization, or you're pretty convinced that there is a need for like automatic systems that take an information source and condense it and present it, taking into account the needs of the user? What are my needs now? I asked a question. I need an answer. Verbal.
I think we're good.
Okay, good. So actually, researchers have done a bunch of studies to actually prove, like with numbers, that yes, it sounds like a good idea and we can get benefits if we kind of build interfaces that integrate summarization. So this is in a large study that was done before I was even a PhD student, so kind of trying to prove that summarization of single document news would be helpful. So they simulated this task-based evaluation where they wanted to see whether having a summarization system would help for information access. And kind of the task scenario was work of intelligence analysts. So you want to make sure that America is secure, you want to read a lot of news, you want to not miss news that are related to a topic that's relevant to your interest. So you can either look at the full article, or you can also have the summary and the article. And it turned out that summaries that were 70% of the full text length sped up decision making, and here the decision is this piece of text relevant to the topic that I'm studying or not, with no significant degradation in accuracy. So people made decisions faster, and they didn't make, their decisions didn't get worse, so they didn't miss important information that they shouldn't have missed. And same with query focus. So these summaries, the first type of summaries were generic. It's like you're given a document and the system produces a gist of the document. Query focused is where actually the system is also given this topic of interest that the user has. So query focused summaries actually are even more helpful, and they help users find more relevant documents more accurately with less need to consult full text documents. What about?
I have a quick question.
Yes, thank you.
So it seems like an obvious place for that type of summary is snippets for web search. Do you know if Google or Yahoo or any of those guys are working on doing anything more sophisticated than just grabbing the N words around your query term?
They are doing, and one thing that so it's kind of for the query focused, actually there has been less work. So kind of summarization people for a while were working much more on the generic, what is this about, rather than how does it relate to a user query. And one problem with single document summarization, the way I was describing it here for news, for this specific genre, is that actually the first line of a news article is very good baseline. And actually in many evaluations, people try to come up with better system, and in no manual evaluation did a system ever beat the baseline of the first sentence for news single document summarization. So like whenever you make these claims about evaluation and summarization, you have to be very careful to explain in what of the instantiations of summarization are you talking about. So this was news single document. And so this is one reason why actually people kind of have given up on single document summarization, because you can do very clever things and you still can't get any sort of kind of, yes, this is always better than the first sentence. But what people want now, and what I know that both Google and Microsoft would like to do, is there is this problem when you show news and you show a full sentence. The person who wrote the sentence says, hey, this is my intellectual property. You can't put it on your website. So now the company, and you have seen, like, if you have noticed, if you read Google News, the summaries, like this initial snippet from the article, has gotten shorter and shorter because there was this lawsuit in Europe. So they cannot display the full first sentence. So there is a lot of interest in, okay, how can we kind of take the first sentence and regenerate it in a way that it's no longer their sentence, so we can still put it on the website. So there is this, I mean, there is work going on in research labs, which is, what if we don't just pick one sentence, but we modify it in some way so that we can put it as long as we need it, kind of. Very often for news summarization, the desired length is at least a sentence, if not more. The more you see on kind of engines, it's like even a part of the first sentence, which is frustrating. And the reason why they show you a part is because they haven't figured out how to kind of regenerate the sentence so that it's not exactly the original that has intellectual property issues linked to it. But going to another task, which is multi-document summarization. So what if you don't have a single news article, but you have a bunch of articles that are on the same topic? And can you produce a summary that tells you what is the shared topic for the articles? Then many systems do way better than the baseline. Then you can do really interesting things. And producing multi-document summaries reduce search time. So when I'm searching for something, if the relevant answers are clustered into similar documents, and you have one summary that's multi-document summary and tells you what the similarity between documents are, and single document summary that tells you what is the unique thing about an article. This has been found to be really liked and useful for users. And sometimes I wish this was the current, I don't know why current interfaces aren't more like this. Like when you look for something, most of the hits are kind of very similar. And you're wondering, is there something that I'm missing? Like, should I keep reading lower in the list? So for this, I don't have a good explanation of why Google, for example, is not trying more of that multi-document summarization. So here are the examples. You have all seen Google News. Again, this idea, you group together similar articles, you provide a summary that tells you what the articles are about. Very often you would see that they won't even give you the full first sentence for these reasons that I talked about. I actually want to mention briefly two research systems that actually predated Google News, where people working on summarization was saying, oh, we need these kind of portals for news where data from the web is collected, and you have articles that, summaries for articles that are on a similar topic. So this is the News Blaster system from Columbia, and there actually the summary is real summary produced by a kind of research summarization system. For each sentence, you have a link. You can, if you are interested in the information, you can go to the article, and there are a bunch of kind of research questions that are interesting and kind of ongoing research. So for example, getting perspective. So for the same piece of news, can I see what the United Kingdom says and what the American sources say? Are there differences? So you can get summaries from different perspectives, for example. And this is kind of an open area. How do you find contradictions and similarities and differences in opinions? And also event tracking, doing these timelines of an event. So how does this relate to the news of yesterday and the news from last month? So these are kind of interesting ongoing things in summarization for that. The other system for news summarization that predates Google News is News in Essence. So this is Drago Radev's system from University of Michigan. And he has a bunch of features that are kind of different. Like, this system has the option where you can upload your own cluster. And I don't know, like, I always wonder, like, who would be the person? I would never go and find my own cluster and upload it somewhere. Users are lazy, but what I really like in this system is they say, well, give me a website that has information that you like, and then I'll automatically crawl the web for other relevant information, and I'll give back summaries of what I found. So these news troll features are really cool, and probably something that we would need in the future to manage all our information. So what are the tasks in summarization? Now that we have kind of gotten some flavor of what the different instantiations of the task can be, well, there's content selection, right? So you have to find the important content in your input. And very often for text summarization, this really boils down to finding important sentences. So you have a text, what are the important sentences in this text? But then once you find these sentences, you have another question, which is, how do I order them, right? So I was saying, especially for multi-document summarization, it's really useful, but in multi-document summarization, you can choose sentences from different documents. So in what order are you going to present these sentences? It's a decision that you need to make, and that will make a difference in how readable the final summary is, right? And finally, you would want something like automatic editing. You want some sort of generation capability. At a minimum, for example, if you have chosen a sentence that has a pronoun in it, and this pronoun does not have its antecedent in the summary, you probably want to put the real name there so that it makes sense in the context of the summary, right? And I guess it's fair to say that the lower you go on the list, the less work, kind of published work you see. Why? Well, because content selection has gotten easy. People have figured out easy enough ways of finding important information that work, and they kind of feel they can do more of the same. Information ordering and automatic text-to-text generation are really hard NLP problems. So they're really kind of open questions. There is work going on. I think it's unfair to say that there isn't work, but it's definitely less than the work you would see on content selection, where people would tell you, I found a new machine learning method or a new feature that helps you find content easier. Like, you find more informative pieces. So I have totally overestimated my abilities to talk quickly, because I was planning to tell you some things on each of these three, and then I have three more things, which is, so tell you some of the approaches on text summarization for these three, and then go to speech summarization. So really kind of give me indications if you're interested or not, because I can speed up or slow down. I definitely will not be able to cover all of my slides. So I'm starting with content selection. How do we discover, and what I'll be talking now for the next 20 minutes is in text. Have a piece of text. You want to find what are the important sentences that you would want to put in a condensed summary. So again, here in this situation, I'm actually probably talking about generic summarization when there is no user query. So you have the document and you just have to produce a summary that's kind of representative of what's in this document if someone is looking for information and wants to quickly decide whether a document is relevant or not. And probably the most used feature that actually was proposed in 1958 was frequency, and it's kind of very intuitive, right? If you have a word reappearing over in your text, probably this is what your text is about, so probably the sentences you select should have this frequent word. And in multi-document summarization specifically, there have been studies that show that indeed frequency, both within an article and across the different inputs, are very good indicators for informativeness. So sentences that are repeated or information that's repeated across the input would often end up in human summaries. So the problem is that, well, first this feature was proposed in 58. It works reasonably well, and as I was saying, people try to say, okay, can we do better? And one of the proposals of doing better was saying, well, you know, a lot of the most common words, those that appear most often in text, are function words, right? So prepositions, determiners. So the most common word in English is the. You probably don't want to select sentences with the, because it won't be that informative. So you can't really use frequency kind of directly. Or imagine you are looking at an archive of computational linguistics papers. Probably computational and linguistics are not that good terms, even though they appear often, right? They probably will not tell you anything specific about a given paper. So there is this problem of common words that could be either function words or domain words that are not descriptive at all, but are common. So how do you kind of remove these words from your frequency count so that you can get to the real topics of documents? And in information retrieval, the TF-IDF weighting scheme for words. So how many people actually have not heard of TF-IDF before? Okay, so I'll explain. So what is TF-IDF? So TF stands for term frequency, which is exactly the frequency that Loon suggested to use as an indicator of importance. You just count how many times a word occurs in a document. What is the problem with this? Well, the problem are these two things. Function words are very common, they appear very often, and domain words also are not really indicative of topic, but they appear very often. So how do you normalize for this effect that they appear, but they appear everywhere? They don't characterize the topic of your input. Well, here's where information retrieval people came with this inverse document frequency weight that you could put to a word. So what is the inverse document frequency? Imagine you look at your entire collection. So for look at the proceedings for 10 years of the Association of Computational Linguistics meetings, right? And you look at all the documents, so you have n documents in there, many, hundreds, and you then look at the document frequency. So this DF would be how many documents mention the word linguistics, right? So what do you have? Now you know how many documents you have in total, and you know how many documents mention your word that you're interested in, linguistics. And the closer the two numbers are to each other, the less descriptive the word would be, right? If every paper says something about linguistics, then the fact that you have the word linguistics in a given article doesn't tell you anything. All the other articles have this word as well. So it doesn't tell you what the topic of the one that I'm looking at is. So if you look at this number, so n, the number of all articles, divided by the number of articles that contain a word that we're interested in, gives us a good indicator of the uniqueness of the word, right? So the fewer documents have the word of interest, the more descriptive it is in the documents where it actually appears. So the TF-IDF weight is just multiplying these two factors, term frequency, how often did it appear in the document, multiplied by the logarithm of n over df. And notice that when you have a word that appears in all of your documents, like linguistics in the computational linguistics proceedings, or in collection of documents of English text, then n over df would be 1. So the appears in all documents. You can't find a document without the. And this means that logarithm of 1 is how much? 0. So the weight says, if you see the word the, it has weight 0, so don't worry about it. It's not a topic word. Look at other words. Look at the frequency of other words. So this is the TF-IDF weighting scheme, and it's supposed to be a big improvement over just straight probability or frequency of word. And this is a feature that's used all over the place in summarization. Like, if you read a summarization paper, very good chances you'll see TF-IDF. It's kind of domain word. You need to know what it is. Probably most people would not even define it. They assume that you know what TF-IDF weighting is.
So it's not a good discriminator.
Not a good discriminator for, so yeah, it's not new. So if you see TF-IDF in summarization, you can say, okay, tell me what's your contribution. What else did you do? They want to hear about one more, kind of like the really complicated scheme of using frequency in summarization, which actually it's kind of good to understand this one because it turns out to give the best results. So this is better than TF-IDF. But it takes more to explain. So do you want to just take my word for it that there is a better way of using word frequency, or do you want the story of how you can get this better count?
The story, yeah.
The story. Oh, so you're missing on, you're missing on all the other interesting stories that I have. Okay, so you have a term, T, and again, remember what we want now. So we want to be doing our counting, how often things appear, but ultimately the reason why we're doing counting is because this is now our definition of understanding. We're not doing relation extraction, no real processing in a way. What we're doing is we want to count stuff, and then at the end we want to be able to answer this question. I have a word in my document. Is this a descriptive important word? Why do we want to answer this question? Well, because then we want to extract sentences or parts of sentences that contain these words. So T is the word, the term that we want to decide, is it descriptive of our input or not? And then we also have a cluster of articles on a given topic, our topic of interest, and then a bunch of other articles that we know are not on the topic. So in a way, if you think about multi-document summarization, what you have is your articles that you need to summarize that are somehow related to a topic, and then you have the background of all sorts of other English news that are not related on the topic. So this is your input, and now you will be doing a lot of clever counting so that at the end you come up with a binary decision, which would be yes, the term T is descriptive of our input, or no, this is not a word you should consider as important. And kind of talking in terms of kind of statistical hypothesis testing, and if you don't know what this is, don't worry, you don't need to know to understand it, but you can have two hypotheses. So what does it mean for a term to be descriptive of the input? Well, the term has a probability P, right? And the probability is one really nice thing about probabilities. You can get them by counting, right? You count how many times your word appeared, you count how many words were there total, you have the probability. So probabilities are good because they're easy. And you have two possibilities about that probability. Well, you can have in your T, the cluster of articles on your topic, the probability of your term might be some P. That's exactly the same as the probability of the term in the non-topic documents. So are we interested in this term, if this happens to be what holds for it? No, right? It's not, it has the same probability, so we have no reason to believe that it's in any way descriptive. What we're interested in, the second hypothesis, where we have one probability of the term for our documents on the topic, and this probability is different from the probability of the word appearing in the non-related documents. And moreover, it's actually higher. So kind of seeing this word for that particular topic is more likely than for any other kind of general collection of news. And so these are very good hypotheses, but exactly what do we need to calculate, right? So at this moment, we only know how to calculate the probabilities. So these, the P, P1, P2, we can easily calculate, right? You learned this the other day, yeah?
So is there reasoning behind why you don't look at the less than as terms that if this is present, this is not likely to be part of this cluster?
Well, remember, because I want to use it for summarization. So if you find a word that appears in other documents but not in your input for summarization, how are you going to use this to select which are the important portions of the input for summarization? It's useful information, but not if you want to use it for our ultimate goal. In a way, if you're just using these probabilities as descriptors of your input, you might say my input is this but not this, right? But so in some sort of visualization environment, probably you could use it, but getting terms where P2 is higher will not be that useful for content selection and summarization. So how many people know what a binomial distribution is? Oh, so then how many people don't know what a binomial distribution is? Excellent. So I now told you what we need to do. Remember, we need to figure out what these probabilities, the conditional probabilities of the term given the topic articles or the non-topic articles. Well, now we look at a text. Each word is one Bernoulli trial. So you have a word and you wonder, is this my word of interest or not? Right? So overall, for a full text or a full collection, what you can calculate is, well, if I believe that my word has a probability P of appearing in a text, and I saw N words in my input, what are the chances that I'll see my word appear K times, right? So this is the binomial distribution, and this is exactly what we can use to calculate these conditional probabilities, right? So now we have the way of calculating the conditional probability as well. How? Well, for each portion of the data that we have, we'll use a binomial distribution to see the likelihood of the event of seeing that many occurrences of our word in a corpus out of that many words. And here you'll also use, like the only kind of tricky thing is, how would you do our counting here? Well, here in this hypothesis, you merge your articles on the given topic and the background articles. So T and NT just form one collection. So under this hypothesis, you have no reason to believe that you should be separating them. And then you do your count for P. So you find the probabilities. So this is what you compute your binomial distribution over. While in this hypothesis, you say, oh, I have two clusters that I need to keep different. So the likelihood of my data is the likelihood of seeing the word that many times in my topic documents times the probability of seeing my topic word in the non-topic documents, right? And these are independent because I have different types of data. So this is all you need to actually compute this likelihood. So you have the likelihood of the data, so it's what you observe in your T and NT divided by the likelihood of the data given the second hypothesis. And you can compute this just using binomial distribution. Even after all this talking, ultimately, what do? You count words. But as a result of counting words, you get something that's really neat, which is you compute this ratio of the two likelihoods, and you know that this minus 2 log lambda actually has a known statistical distribution. So what does it mean to have a known statistical distribution? Well, if you say the value of my amount there is 5, you can go and look up a table and say how likely it is that I'll get 5 by chance. Like, is there something kind of really going on, or is this like random number that I would have gotten in any sort of situation? And what you want is to get numbers that are unlikely to happen by chance, right? And if you get a quantity that's unlikely to happen by chance, you can say, hey, I'm done. I now have a term that I know is associated much more strongly with my input than with any other text. So now I have found another word that has been used a lot in summarization paper is this topic signature term. So I have a topic signature. It's indicative of the topics of this document. It appears in the documents much more than one would expect by chance. So I have good indication that this is a topic term. So now, when you select a sentence, what would you do? You'll just try to find sentences that have more topic signature words, right? So these words that pass the log likelihood ratio test. And actually for summarization of multi-document summarization of news, using just this feature, presence, number, kind of average density of topic signature words gives really good output for content selection. So finding important content is just this. You find the topic signatures, and then for each sentence you find the average number of topic signatures in the sentence, and you can either just use this kind of greedy weighting scheme to decide what are the most important sentences, or you can incorporate it in a machine learning method. So for example, in HMM, where you have some dependence between the sentences, you can get slightly better, but bottom line is, even if you don't use any fancy machine learning, this feature is pretty good for content selection and summarization. And again, many systems use it. It's not as common as TF-IDF, but again, you can see topic signatures in many of the papers on summarization. Yes?
So, 2 questions. Do you have a sense for why this performs better than TF-IDF? So it's much more principled, but TF-IDF has the same motivation.
So actually, I wondered the same question, and I have a paper on this, which is, so TF-IDF is a weight, right? It doesn't give you, yes, it's descriptive, no, it's not descriptive, it's a weight, and it varies. So one thing that you can use with the topic signatures is you can use the weight, which would be the size of this statistic, right? Or you can use a binary decision, yes, it's a topic signature, no, it's not. So you use the cutoff. So if you use the log likelihood ratio as a weight, you get the same results as TF-IDF. So it's this ability to say, yes, this is descriptive,
So
that makes the difference.
The next question would be, can you select a cutoff for TF-IDF that gives you the same results as this?
It's a different model. I mean, it certainly, I mean, that's a log probability that yet. But,
Why would you want to do, I mean, once you have this, it kind of, how do you motivate the...
Let's say you could do that. Then the answer would be that you could select the cutoff for TF-IDF that would give you good results, but no one really knows how to do that. This does it automatically for you.
Pretty much, yeah.
I mean, you could set up a hypothesis test with TF-IDF, but it's a different It's a different model.
Not really, because for TF-IDF, depending on how many documents you have and how long your document is, so you can say, you can even set a weight for frequency with the same reasoning, right? You can say, I don't want the most frequent words, and I don't want the least frequent words, but I want something in the middle, which is exactly what Loon in his 58 paper said. We want these cutoffs, but if you have a longer documents, the overall counts grow. So how do you decide for this particular document what is a good frequency? So you can set it up as a question. You'll need to convince me more that it's a good question to solve.
There is an argument that of independence, and whether or not certainly a term occurs once and it could occur again. And that's one of the arguments for TF-IDF was that. Just that kind of swept that under the rug, but it's not modeling it, it's sort of ignoring it in a crude way, it's modeling.
Anyhow, moving on, more frequency. So up to now, what did we count? Words, right? So we were saying we'll count words, then for sentences, we'll take words as an indicator of importance of sentences, and this is how we'll figure out which the important sentences are. And by the way, notice that at the moment, remember this definition in the beginning, so we extract the meaning of the input and then we generate. So all this counting, we were extracting the meaning for automatic summarization, genre independent, domain independent. So this is the easy stuff that you can do when you don't know what domain your input will be and exactly what it will be talking about. Similarly, if frequency is such a great indicator, you can say, why count words? Like, I want to ultimately select sentences. For multi-document summarization, maybe I can use some clustering technique to find sentences that are very similar and appear in different articles. So here you have 3 sentences coming from 3 different documents that are part of the same cluster for single document summarization. And if you look at these sentences, what can you say? Why were they clustered together? Yes, there is a strike, right? So they kind of convey the same information. They share this overlap. And we have this cluster. So what do we know now? A lot of our input articles convey this fact that there was a strike. Well, remember we said that in a kind of really idealistic setting, we have a cluster of articles. We want a summary of the similarities, and then for each article, what are its specific differences with everything else. Picking one of these sentences is a perfect candidate for saying what's common, right? This is how we found the cluster. We clustered sentences, and we hope that we have sentences that convey the same information. So the bigger the cluster, the more repetition was there across our inputs, the more likely it is that one of these sentences should be in the summary. So this is another way, and this has been done as well in summarization, but not as much. So why not as much? Because there are actually neater ways of kind of using both the word frequency and the sentence frequency, and they're actually pretty good kind of formal models. So graph-based representation for summarization is again something that you would see a lot if you read papers, kind of more recent papers on summarization. And what is this graph model? How do we get from text to graph? Well, imagine each sentence is a node in your graph, and you have edges between nodes. So what are the edges? Well, the edges you can compute using sentence similarity, right? And again, like you actually would be using TF-IDF to weight your vectors, but so you're getting more and more complicated, but you're still using these first counting techniques that people came up with. So again, each sentence now is a node. You have edges between nodes, so 2 sentences are connected, and the weight of the edge is equal to What? It's equal to the similarity between the two sentences. How do you compute similarity? Well, you compute similarity between sentences based on the words that they share, right? So here is what a graph might look like. So each node here is one sentence. So the thick links, the thick edges are edges between sentences with similarity that fall in the range between 1 and 0.3, and then they go to lower and lower, and some sentences are not even connected. So for example, these two, they are D1, S1, so this stands for document 1, sentence 1, and document 2, sentence 2 seem to be very similar. And we can take a look now at what the sentences were. So they were: Iraqi vice president announced today, Sunday, that Iraq refuses to back down from its decision to stop cooperating with disarmament inspectors. And then the other sentence is: Iraqi vice president announced today, Thursday, that Iraq rejects cooperating with the United Nations except on the issue of lifting the blockade. So they share some words, so there are some facts that are common. And again, why was I saying that this model kind of uses both word frequency and sentence frequency? Well, it does because what links sentences? Co-occurring words. So if a word appears a lot in the document, it will link a lot of sentences. And how do, like, what is a cluster? Well, if you have, the more links you have, you know, if I look at this sentence and look at all the other sentences it's connected with, I can almost have a way of doing clustering, right? I can say, I'll take this sentence and all the other sentences that have high similarity with it, and I'll form a cluster. So in a way, you have this implicit counting of words and counting of sentences in this model. But it's like really great. So now we have the graph. How do we select a sentence from this graph, right? Any idea of those? Throw a dart. This is a possibility, yes. Pick the one with the highest weight of?
Sum all the weights, essentially, an average.
So sum up all the weights that go into a node and say, so this is, in a way, what you're suggesting is exactly doing the clustering, right? It's like, get all the evidence that comes from other similar sentences and use this as the importance for the node. And you're very close. So what you're suggesting is the first step what people normally do. So there is the kind of random walk model where you can actually normalize these weights and similarities to get a probability distribution, and then you can imagine that this is a graph, and kind of now the edge weights are actually probabilities of transitioning from one node to another. And you can just kind of start jumping around the nodes, and if you do your random walk for a while and you stop and you say, oh, I'm in this sentence, I'll select this. So right, kind of the idea is that the more popular sentences, you're more likely to be kind of visiting them at any point of time. And what I just said is supposed to give you the intuition, which I actually sometimes find very confusing. The neat thing is that you can actually just do the summing of weights and redistributing of weights in a iterative way. You do 20 or so transition, and you find the stationary distribution, which is exactly the probability of being in a node at a given time. And like you can just look up the formula for a stationary distribution and compute this. So this is the really cool thing about graph-based models, is there not only you have this representation of the text, but you can run the page rank, or I mean, I don't even think we need to call it page rank. You just turn this into a Markov chain. You find the stationary distribution of the chain, which gives you exactly the likelihood of each node. So again, bottom line is you have for each sentence a weight. You know what is most important. The most important thing should end up in your summary.
I have a question actually. So after you've chosen one sentence, do you then remove its edges so that, like I would, to try and avoid redundancy?
No. So in the kind of the importance part, you don't remove anything. So you just like run it once and you get the ranking. What you're pointing out is a good problem that I was kind of not mentioning, which in all, actually not just for this method, for all of the methods, for multi-document summarization, if you have a sentence that's ranked really high, you probably will get a lot of similar sentences that are also ranked high. And you don't want to include both because they will have repetitive information. And in fact, this is the reason why people started doing the clustering, sentence clustering, because there you can select only one sentence per cluster and ensure that you kind of are avoiding repetition. Otherwise, you have to take care of this separately during your selection process. And I haven't talked about the selection process much, but probably the most widely used. So almost as TF-IDF, the stuff that you see in summarization, another thing that you will see almost in every paper is maximum marginal relevance, which was this idea that when you choose content and you choose it in this greedy way where you're selecting sentence after sentence, what do you have? Well, if you have a query, you want your sentences to be relevant to the query, but also you want your sentences to be maximally different from anything that you have already chosen to be included in the summary. And you can vary the weights of how much you want kind of relevance to the query and how much you want difference from what you have selected. And by setting these two parameters, you get the maximal marginal relevance. So you want relevance, but kind of marginal because you want to take into account what you have already put in the summary. So this is the bottom line thing. And then if you ask, well, can you do more interesting things? It's an open question. Actually, people who do textual entailment, where they take two sentences and try to figure out whether the two sentences have a shared fact, are using data from summarization to kind of test their systems. It's an open NLP question. How do you do it? You can always do it better. Kind of the maximum marginal relevance is more of a kind of the easiest thing that you can do to ensure that at least some reasonable level. But yes, like more is needed to get a really good system. I won't talk about machine learning, but I want to just point out that what I was talking up until now is really very data driven. Like you don't know what is the right summary, right? You just kind of count things in your input and you decide this must be important. There is no feedback or input from a person saying, I think this is important. And they're complementary methods. Like you can go the data-driven way, or you can say, well, I'm really into machine learning. I'm going to ask a bunch of people to get the input, select sentences that they think are important, and then I'll use this as label data for machine learning to figure out what are important sentences and what not. And then you can start saying, well, you can use naive Bayes, but if you try SVMs, they're better, and if you put in an HMM, it gets even better, so you can do all the usual stuff that you do with machine learning. Information ordering. I can't decide about what to tell you about. Information ordering. Let's say I'll skip information ordering. If you're really interested and feel like it was a big loss that I didn't go over this, email me and I'll tell you about the paper. We can talk during the break a bit. So information ordering, pretty much the short answer. A lot of people have started kind of from summarization and are kind of saying now, well, it's really hard problem, so we'll just solve it as a separate problem. How do we order information? And then when we're done, we'll come back to summarization. There is the one model that is not general. It only works if you have domain specific. So if you know what sort of domain your inputs will be coming from. So then you can do something smarter that you can actually integrate in summarization and has been integrated in summarization. But I won't talk about it, and it's kind of only one kind of direction of work. Bottom line is very interesting, very open area for research, information ordering. The same for automatic summary edits. Again, I will not get into this, but you can imagine how, like here's just an automatic summary. You can imagine that there are all sorts of problems. If you get multi-document summary, you're just extracting sentences, putting them together. They don't read well as a text. The longer the paragraphs gets, the worse the more confused the reader would get. So things that have been done is thanks to the more the systems that already exist for information extraction and enough for resolution, you can at least correct problems such as names. So if you have people's names that appear without any description, you can actually automatically now supply the description so that at least the flow of references seems better. But really, overall, this kind of post-editing of the summary and kind of text-to-text generation is, again, very open problem on how you can do it. There is another work that, again, is almost being done now outside of summarization, which is sentence compression, right? So what if you select a sentence, but this sentence has some information that you want to keep and other information that you'd rather not keep because it's not important? So how do you automatically condense a sentence or compress a sentence so it still stays grammatical but doesn't contain this extra information? Or the other kind of sentence compression work is how do you generate a headline? Maybe you'll select one sentence, but then you'll really compress it to only 10 words. So again, I don't have time to talk about this, but work has been done and people are working in this areas of summarization. So preferences. Summarizing scientific articles or summarizing speech input? You can only do one, I think. Speech. Okay. I just want to say the scientific articles, though, is really neat. Like, we all need it. Like, how many times you wish you can write your related work section and you wish there were better interfaces to databases with scientific articles where you don't just get a list of articles, but get some sort of indication of how articles are related and what is common. So to me, this is fascinating, kind of the summarization of scientific articles, because I feel if it works, I want to use it. So this is why I thought that I want to include it. And actually, there has been several, there is active work in this area. So there is hope. Probably we will have better digital libraries soon. So let's talk about speech. The reason why I wanted to talk about speech is because I started out saying, well, it depends on what your input is. And then I told you a bunch of things about text and sentences. So would any of what I told you carry over if the input is not written news, but say broadcast news? What do you think?
I thought that was content free.
What is content free? The speech or my question?
No, broadcast news.
So one thing that's going to be different is that the first sentence is no longer going to be a perfect summary of the document.
Right. So you're actually, in a way, what you're saying is there's more need for summarization here. Because actually there's so much audio. Everyone tells you, we have more and more audio that we have available. We don't know how to access it. We don't know exactly how to index it. We don't know what is the most convenient way for browsing. So in many ways, I would agree with you, kind of this question for audio access and retrieval, and thus for audio summarization, is more pressing. And if we know less how to do it, but if we found out a way to do it, it would be kind of really like new level of how we experience information.
So also, everything you've talked about so far has been extractive summarizations, where you assume that there's good sentences.
I just said that I'm skipping the non-extractive part just because I have 15 more minutes. Yeah.
Well, what was it asked is for speech is the focus on non-extractive? Or is it still non-extractive?
I will tell you some, but yeah, for speech actually there is more reason to be non-extractive, but some of the people in the room might not immediately see why. So we'll talk about why you would need to do more non-extractive for news, for speech. So here are the kind of subgenres within speech that people have worked on. So broadcast news, are they, what was it, vacuous? No, content-free? They might be, but sometimes, especially in this intelligence analyst scenario, you want to see what kind of people in the Arab world hear on their TV programs. So you want to monitor, you want to be able to access, you want to have brief summaries, so that if something interesting or of interest to you happens, you're alert. Another subgenre within the speech summarization, the adic conversation. So there is the switchboard data that a lot of people have worked on summarizing telephone conversation. If you ask me, the telephone conversation is the least interesting. But if you go to multi-party conversations, so meetings, what if you miss a meeting and you're manager of some sort, and you want briefly to very quickly see what was discussed, what were the decisions made. You want to be able to have some sort of summary of the meeting, right? So for multi-party conversations, there are a lot of people that would love to have a system that helps them browse meeting recordings and get overviews and summaries of meetings. Lectures and presentations, again, this is something more relevant to kind of academically inclined people. You want to be able to take a presentation, or there are a lot of schools that have their lectures from their professors, their classes are taped. So now they're taped and you have the best professors at the best schools giving a lecture. How do you give access to people remotely to these lectures? You have to do some sort of browsing interface and summarization so that people can figure out like what lecture they want to see, which part of the lecture, right? So I think personally would be more excited about these two, but people have worked as well on broadcast news, mostly because funders are interested in broadcast news. And the telephone conversation, I would just say the data was out there, so people worked on it. So what is different when the input is speech? Well, you might not have text, right? Where would you do all your counting if you don't have words? You just have acoustic signal, right? This would be really disturbing for someone who has worked a lot in text summarization, because there's nothing to count. What are two good things that can happen is, well, it can happen that you're given to summarize speech where you also have a transcript. So the transcript is someone has written down what the speech is about. Not is about, but kind of word for word, you now have a written record of what the speech was. So this would be very comforting for someone who does text summarization, because they can say, well, forget, like, the speech signal is continuous and scary, and we don't want to do anything with it. We just want to count our words, so we'll take the transcript and we'll do our usual stuff. And this works, it has been done, and you can get some good results. The problem is very often you don't really have a transcript. And some really interesting work kind of recent years, and I'm almost dubious that like I feel like this needs to be verified, this cannot be true, that just based on acoustic features, so pitch and intensity, you can actually do good summarization of broadcast news. And kind of, I mean, it does sound like magic, right? It's just you measure the signal and then you find snippets of the audio that are of high importance. And kind of one of the explanations that is given for this is this works specifically very well for red news. And the reason why it would work, kind of the explanation is that, well, news anchors, when they read the news, they're actually trained to emphasize what is important. So by tracking the changes in their voice, kind of trying to detect emphasis, you find these regions of importance, and it has nothing to do with words or counting. It's just the way their voice changes, like to make a pause between something that's important, or to say it louder, or something like this. So this is the explanation of people who believe that it's a true result. Like I feel I need more analysis and kind of really to be convinced that this is true.
Has anyone tried doing this with, say, phone records to see if this would, to verify this, check that it doesn't transfer over with people without this kind of training?
So there are 3 papers, and for anything that I said today, if you're really curious, just send me an email or ask me, because the things that I put on the slides are in papers. So there are only 3 papers that talk about these results, where you do summarization with audio only. 2 of them are on broadcast news, and the 3rd one is broadcast news and lectures. And the results for lectures are actually worse than broadcast news. So you would say, well, I'm not trained really to deliver presentations. So in a way, there is some sort of backing of this kind of hypothesis of why it works. But these are the 3 studies that at least I know of. I don't know of others. So it's mostly been done on broadcast news. It has been in one of the, so it has been done both for English, for Chinese, and I believe for Japanese as well. So this is a cool thing. Like you don't have the problem of kind of all this text processing, right? For Chinese, you might have problems finding where the words are to start your counting. But for this acoustic signal only summarization of broadcast news, it has been shown to work for Chinese, and I'm pretty sure the 3rd paper was actually Japanese, so there are 3 languages, so this would be a nice characteristic. So other problems with speech summarization, well, imagine you really want to do some sort of analysis of the text. You don't have a manual transcript. Well, you'll use the automatic speech recognition system, right? We have all this, and I think later, in later days, you'll be talking about speech more in recognition. But so there are systems that are developed to take audio stream and produce a transcript. What are the words that are being said? And they work reasonably well, but not perfectly. And it depends on what sort of speech you have. So if you have something like the red speech of news anchors, you probably would get 10% error rate. So the error rate is the number of words that you would get wrong, not as what you would have in manual transcript. But if you have a conversational speech or more spontaneous speech, the recognition drops to 40%. So it's almost close to like every other word in your transcript is not what the person said. So you can do analysis of these transcripts, but have to be careful about whether you want to trust the results and what to do. Actually, one thing that I want to point out here is that for summarization, very often at the end of last lecture, we're discussing this scenario where you want inputs in various languages and then the output is in English. So you can have a similar problem with text summarization when you want, say, to summarize documents in Chinese or Arabic or Bulgarian and you want a summary in English. Then you would use a machine translation system that also has a lot of errors, and then you have to summarize this errorful input. And so what do you do then? Well, one thing that people have done is say, okay, now we have a modified task. Now we not only want to find important content, but we want to find important content in the portions of the text that we believe have better recognition rates. So now you have another component in kind of what you're trying to optimize. You want important content, and you want to select this content from the portions where your automatic speech recognition systems worked well. And one thing that people have done, like the obvious thing as well, the recognizers actually give you what words they think they heard, but also confidence in how confident they are that indeed the word said is the word that they suggested. So incorporating this confidence scores in your selection, so kind of finding the importance of an utterance and then finding how kind of trustworthy the transcription is, and you combine both scores to get the final desirability of putting an utterance in the summary. So another way of dealing with this is not to use confidence scores, but just use language models, right? You find how probable is a given sequence of words. And if it's not very probable, you can say, well, probably the recognizer messed up, probably there is an error, I'd better avoid this portion of the text. But another thing that you could do is you can say, and part of the reason why you want to do these things is when you output your summary, you want the reader, the user, to be able to read it, right? If you have a lot of errors, will make no sense to any reader. But another thing is, what if, and a bunch of studies have shown that actually these TF, IDF, kind of the shallow metrics for analysis don't get thrown off that much by recognition error. So you can still find where the important information is. Only that now when you give it to the user to read, they can't read it. And how can you solve this problem? Well, you will not give a textual summary, you'll just play the input, right? So you change your output modality and you say, okay, I found a snippet, I think this is interesting, hear it. And then I don't need to worry that the automatic transcript had errors in it. I'll just play it to you. So this is kind of the beauty of kind of this vague definition that I started with. I just changed my output modality and there is no problem to solve anymore. And then of course the other thing is, again, you just say, well, we'll wait till automatic speech recognition gets better. They know what they're doing. At some point, they'll know how to transcribe well, even conversational speech. So why was Mark asking me what happens with speech and do you need to use more sort of non-extractive methods? Because speech is really messy, especially when you look at it transcribed. You can't, like you look at a transcription of a conversation and you wonder, how do people understand each other? So you have an utterance like this, well, I think we should discuss this, with her. So you have this, and what you have said is, I think we should discuss this with her, but you had the, well, all these things thrown in, all sorts of disfluencies, filled pauses. You don't want them in the output. Even if you change your modality, actually it would be good if you can get rid of these disfluencies, right? It would be good if you can just synthesize a sentence that says, I think we should discuss this with her. So in speech, the detection and removal of filled pauses and hesitations and all sorts of these things, a lot of work is being done it's important not only for summarization, so it's work that's done not necessarily by people working in summarization, but definitely summarization people are, they're not as scared to try abstractive methods because this is messy. Like, imagine if you try to change a sentence written by a journalist. Every time your system makes a mistake, any reader would catch the mistake and say something went wrong. Imagine messing up with things like this. Well, they're kind of messy to begin with. If you make some mistake, it will look probably worse, but not that much worse. And especially if you have an utterance like this, which is an actual utterance from switchboard. Look at this. But I think, you know, I mean, we always, I mean, so it's kind of this long hesitation. How much can you lose if you try to pre-process and kind of, again, do this sentence condensation to get this? So one thing that you need to remove is remove the disfluencies. But another thing that's really kind of somewhat problematic for processing in speech is there are no sentences. What do you extract, right? I can make a pause in the middle of my sentence, or I can say 3 sentences without having a pause, clearly demarking them. So another kind of interesting work that's being done in speech is once you have your messy transcripts that have recognition errors, this is what you get. No capitalization, no punctuation. How do you actually kind of insert the punctuation so that the transcript is readable? And then how do you remove the disfluencies and the hesitations and the false starts? So again, it's reads better. And this is the last thing that I'll say. What is the best kind of granularity is a question for summarization of speech is something that people wonder. Like, there's nothing like a sentence there. There's no obvious unit. So you can use pause-delimited snippets. You can use sentences that are determined automatically. So there's no sentence in the transcript, but you can run a trained system. Or you can use intonational phrases. So this are apparently, this is the order. Intonational phrases are best, automatically determined sentences second best, and then pauses are the worst in terms of chunking input. And then adjacency pairs. So imagine something like this, a conversation. Would you like to join us for dinner? And the other speaker replies, I'd first need to check with Alice if she has made other plans. So these are pairs that kind of have to be selected together, right? If you only select one for the summary or the other for the summary, it doesn't make sense. So in a way, you can say these adjacency pairs of pragmatically related utterances are what you should be doing selection over. And people have worked on kind of automatically identifying such pairs and using them for improving speech summarization. And I've run out of time. I should have summarized my presentation better. I can't believe I was so ambitious because I had like about that much more prepared.